So let's start the next problem. Suppose a circular queue of capacity n minus 1 elements is implemented with an array of n elements. Okay, so there is a circular queue of n minus 1 elements and it is implemented with an array of n elements. So I've drawn these arrays, they are identical. So these arrays, you have to think of them like circular queues. So suppose this is the index 0, this is index 1, and so on. You have all these indices up till n minus 2 and n minus 1, like this. Okay, so it has a capacity of n, this array, but the capacity of q is only n minus 1. Okay, so capacity of q is 1 less than the capacity of this array. That's kind of key here. Okay, and then you have to assume that the insertion and deletion operations are carried out using rear and front as array index variables. Okay, so rear and front. Okay, so the front and the rear. So in the beginning, rear and front are both 0. So when you start working on this array, on this circular queue, this is your rear. Okay, I'll just write R for rear and F for front, and this is your front. They both are 0 in the beginning. There is nothing in this circular queue. Okay, so then what you have to do is you have to detect the conditions when the queue is full and when the queue is empty. So what will happen if you start inserting elements into this thing? Okay, suppose you insert something out here. Suppose you say you insert, let's say 10 out here. Okay, and then you insert, let's say 30 out here. So when you inserted this 10, this rear moved to here. Okay, like this. Just I'll insert 30 later. First I should just insert 10. So I inserted 10. In the beginning both rear and front were here, okay, at index 0, and then I inserted 10. So then what happens is that my rear has to be moved. Okay, so rear doesn't point there anymore, it points here now. Okay, that's the rear, or that's the tail of the circular queue, you can say. Okay, and then if you insert something, then rear will move here, out here. Okay, so that's the idea. And maybe you can pop something. So if you sorry, I shouldn't use the word pop because that's for stack. So if you remove something, you remove it from the front. Okay, so if you will remove from here, then your front will move here. Okay, so that's the thing. You insert from the rear and you remove from the front in a circular queue. That's the idea. Then you have to find when the queue is full. So what will happen when the queue is full? This rear, you keep filling things and this rear will keep moving ahead like this. Okay, wherever this full is, we don't care. But you have to remember this thing, that suppose let me remove this rear from here. Okay, this rear is not here anymore. Suppose you have reached out here. Okay, suppose you have some element out here like 80, and then this everything is full. Okay, this everything is full out here. Then what will happen is that your rear will point here. Okay, and can you fill something out here? Can you put another element out here? No, because the capacity is 1 less than the capacity of array. So one cell in this circular queue has to be empty. Okay, and this is the thing. So when is this thing full? Okay, it is full when the next element to what rear points is the same thing what full points. Okay, so rear plus 1 should give me full, but since you are in a circular thing, okay, this full might be out here. Okay, it might be the case that the full is here and your rear is here. Okay, you might have this situation, so you need this mod n out here. Okay, this mod n is this, you take the remainder of n, so this remainder will be between 0 and n minus 1, and that's why this gives you this thing that your rear plus 1 mod n will give you front. Okay, and that thing is correct. Okay, so for full you have this condition. Okay, your rear plus 1, and if you take the remainder with n, by dividing with n, this mod n, it should give you the pointer to the front. So this is this thing is present in A, B, and this is present in A and B. Okay, so A and B, so definitely C is not the choice. C can be eliminated, and D can also be eliminated. Okay, and then what we are left with is we have to check the condition for empty. Okay, so again let's do this thing. So suppose your rear is here. Okay, your rear is pointing here, and suppose this is the last thing that you have to delete. Suppose there was something here, 39 or something. Okay, and then this was your front. Okay, and if you remove this thing, if you take out this thing, what will happen? Your Q will become empty, and this front pointer will move to the next one. Okay, and what will happen in that case? Rear and front will become equal, and that is the condition with this thing, and that's why this option A is correct. Okay, you understand why this happens? Because this is the last element. Okay, we kept on removing, and this front kept on moving. Okay, it kept on moving from here till here and reached here. Let's say it reached here, and you remove this last element, so this front will move here, becoming equal to the rear. Okay, so that's the thing.